Ok, il est 15h05 à Niamey, je pense qu'on va commencer. Donc bonjour à tous, je m'appelle Jérémy Boy, comme je l'ai écrit dans le chat, je suis le lead scientist des Accelerator. C'est avec grand plaisir que j'ouvre cette session sur le Data Powered Positive Deviance, le travail que nous effectuons au Niger. Ce webinaire fait partie d'une série de 4. Donc, on a déjà entendu nos collègues en Somalie, en Équateur et au Mexique. Et donc ici, c'est la 4e et dernière intervention dans cette mini-série de webinaires donc sur le Data Powered Positive Deviance. La session sera partagée entre français et anglais. Donc, j'introduis en français, je fais une petite introduction en anglais juste après. Nos collègues du Niger présenteront en français, nos collègues de la GIZ présenteront en anglais. Et on va essayer tout du long de traduire dans le chat, dans les différentes langues. Donc, pendant les parties en français, les parties en anglais, on traduira en français. Je vais traduire rapidement là en anglais, et puis on fera un tour d'introduction de tous les membres. Je passerai la parole à mon collègue Andreas. So, quick translation in English. Hello, everyone. Welcome to the 4th and last webinar of our mini-series on data-powered positive deviance. We have already listened to the work that is being conducted in Somalia, in Ecuador, and in Mexico. Today, we're going to listen to the work from colleagues, listen to colleagues in Niger and our colleagues from GIZ on the work that is being done around sustainable farming in Niger. The webinar today will be part in French, part in English. So our colleagues, GIZ colleagues will present in English. Basma Albana, whom I'll introduce later, will also present in English. So we will try to translate as we go between, depending on the presentation, the chat, so that everyone can follow. With that, I'll introduce all of the team here.
Jeremy, can you hear us? I think you're breaking up a little. No. Okay, maybe I'll just do the introduction then. I think we lost Jeremy.
I'm back, I think.
Yeah, maybe just turn off your video. Maybe that makes it easier.
Yeah, try turning off my videos for that. So maybe a quick round of introduction if you got into that, Andreas. But then briefly, so Andreas Pavelke, whom you're listening to, is a consultant with GIZ on this initiative. We have on the call from the global, let's say, team of data-powered positive deviance, who's from the University of Manchester. We have Catherine Vogel, who's the head of the data lab, GIZ Data Lab. And a big shout out to Andreas Booker, who is off right now, but who's also part of the initiative here and part of the GIZ Data Lab. And to the team working on the project or the pilot in Niger. From Niger, we have Hassan Chagam Malam Boukar, Rashida Mani Kango Dankulu, and Mustafa Sairou Yakuba. And then from GIZ, we have Esther Bartels and Eric Lehmann. And also here, a shout out to Gunnar Hesch, who's also with GIZ, and to Damien Oswirt, who's the team leader of Eco Consult in Niger, who has been very helpful throughout the work so far. Donc, je ne refais pas l'introduction, mais voilà, toute l'équipe, merci de vous être connectés pour ce webinaire et j'espère que ça sera intéressant. Over to you, Andreas or Andy.
Thanks, Jeremy. So I'll do my part in English, but as Jeremy just said, he'll translate at least the main points. Now, before I talk a bit about the initiative, I just wanted to say that this webinar is being recorded, and we'll also publish it probably next week on somewhere online. Well, you'll find it somehow. Okay, so the DPBD, or Data Powered Positive Deviance, stands for two things. One, it's an initiative. And I'll say a few words about the initiative in a second, but it's also a method. And Basma, who will speak right after me, will introduce you to the method. And I hope some of you, at least, will maybe not be so familiar with it, because we've been doing that for the past 3 webinars. But I think it doesn't hurt to listen to it once or twice, or even 4 times. Now, the initiative was initiated by the GIZ Data Lab, the UNDP Accelerator Labs network, the University of Manchester Centre for Digital Development, and Pulse Lab Jakarta, which is part of the initiative UN Global Pulse. So all of these organizations have very sort of specific and deep expertise in areas that are required to actually make DPBD work. So from data crunching to ethnographic field work to very specific domain expertise that's needed to actually make sense of the context that we work in. Now, when we started the initiative, or when these 4 organizations started the initiative, we knew that we had to test the method in different contexts, in different countries, different challenges. And so that's what the 4 pilots that we've been talking about over the past 2 weeks are doing. There's more work being done, and you can find out more on the blog. Maybe one of my colleagues can actually share the link to the Medium blog, where you find more information on the initiative. I'll do so after I'm done here. So what's important is that there's, again, as you might have heard over the past 2 weeks, different challenges, different countries, different sectors, but all of the pilots have one thing in common, and that one thing is actually made up of two factors. So one is that we believe there are solutions out there, local solutions that work. And more often than not, these solutions are being developed or identified by people actually facing that problem. And the second one is that we believe that in large data sets, that is at our disposal nowadays, so often referred to as big data, there's signals in the data that we can find that point us to those solutions. So all of these, all of the pilots, including the one in Niger that you hear about today, is based on those 2 assumptions. Now, as I said earlier, there's more work being done outside of these 4 pilots. There's a lot of research that we do. There's a lot of documentation, documenting lessons learned. We'll be publishing more and more of that over the next few weeks, including a handbook on how to do or how to apply DPBD. But with that, I'm handing it over now to Basma to introduce us to the method. And as Jeremy said earlier, Basma is a researcher with the University of Manchester, and she's the one who co-developed the method that we're applying here in the pilots. Over to you, Basma.
Thanks, Andy, and hi, everyone. So to begin with, we need to first understand what is the positive deviance approach. And the positive deviance approach is based on the observation that in every community, there are individuals or groups who are able to achieve better outcomes than their peers despite facing similar challenges. And identifying those positive deviants and trying to scale their practices and strategies is what is referred to as the positive deviance approach. Its application has been reported in more than 60 countries, and its application range from enhancing pregnancy outcomes until like limiting HIV transmission. And with the growing availability of digital data sets that are capturing the outcomes and could act as indicators of performance for individuals and groups and spaces, this led to ask the question of how can we leverage the positive deviance approach using big data? And in order to answer this question, it was important at the very beginning to identify the opportunities and the limitations of using big data in this approach. So among the opportunities of using big data, that positive deviance, the way it's done currently, relies heavily on primary data collection and field observation, which includes significant time, cost, and risk. And the opportunity that comes with big data is that it's data that is most of the cases readily available and could be collected at a low cost. So this enables us to reduce the initial time and cost in the identification of the positive deviance. Another added value of using big data is the level of aggregation. So whenever when big data is available, it's available at a large geographical scale. And this large geographical scale enables us to not only look into individuals, like how it was originally introduced, but also to look into units that are above individuals, like villages, regions, or communities. And this also large geographical scale enabled us to identify a larger number of positive deviants. And when we have a larger number of positive deviants, it would make it possible to generalize the conclusions from this larger sample. And there's also the advantage that comes with big data, which is the longitudinal coverage. So it enables us to observe performance over time and not just observe performance at one point in time. And another value that we're coming also to identify by applying data-powered positive deviance is expanding the scope of positive deviance. So instead of just looking into individual factors and practices and strategies, this huge geographic coverage enabled us to look into factors beyond individuals, supra-individual factors such as policies, interventions, and systemic changes, and seeing how those communities are responding to those changes. But we're also aware of the limitations of big data. So big data is usually decontextualized data, and it's being stripped out of context in order to be useful and to have this huge coverage. And this requires us to add and complement and augment this data with traditional data sources and thick data from observations and ethnography to add meaning and value to it. Also, big data, as it's able to explain what is going on or who the positive deviance is not able to explain the how and why of what we're seeing. So just to sum this up, the difference between the positive deviance approach and the data-powered positive deviance approach lies mainly in the type of data used. So in the positive deviance approach, we're relying on traditional data, but here we're relying on traditional and non-traditional data, such as online data, Earth observation data, and satellite imagery. When it comes to the performance measure, the positive deviance approach is relying mainly on manually recorded or observed measures, but the data-powered positive deviance is relying on digitally recorded or observed measures. When it comes to the performance view and the positive deviance approach, the design of the research is mainly cross-sectional. So you look into performance in one point in time, but in the data-powered positive deviance, you can look at it in a longitudinal design, more of over time. And as I said, like unit of analysis, we're able to see beyond individuals, and for explanators or things explaining performance, we can look into supra-individual factors in addition to the individual factors. So how do we go about the data-powered positive deviance method? So the first step is to make sure that this problem is a problem that could work for positive deviance in general, and then see if data-powered positive deviance is applicable. So to be applicable for positive deviance in general, this problem should be an adaptive problem, a problem that requires a behavioral change, and it won't be solved by just a technical solution. The second step is to make sure that positive deviants do exist. And this is something that you could know by qualitative inquiry or by looking into the literature and just having hints and signals that there are outperformers in this field. The second thing is, when it comes to data-powered positive deviance, is to make sure that DPPD is suitable. And this entails making sure that we have access to the data and the capability that would make it possible to apply a DPPD. And then comes the question of desirability and making sure that we are not doing any harm to the observed units and there aren't any unintended negative consequences from applying the approach. The second stage would be to start determining and identifying our positive deviants. So we have to first make sure that there is a performance measure, a digitally recorded performance measure that is able to capture the outcomes of our study population. The second step would be to make sure that we're identifying positive deviance within homogeneous groups. And by doing so, we are reducing the likelihood that there are structural factors that are driving the performance, and increasing the likelihood that the practices that will be identified at the end would be more about behavioral and individual factors. And then comes the stage of identifying positive deviance within those homologs. And because with big data, there's a lot of noise, there needs to be the PD validation step where we filter those potential positive deviants and identify positive deviants that are worthy of the field investigation, which is the time and labor intensive process. So you can look at it as a funnel. You start with populations, with a large population where you can capture its performance digitally. And then you narrow down this population into homogeneous groups. Within those homogeneous groups, you start identifying positive deviants, potential positive deviants, and then you start validating that they are true PDs. And finally, you do the qualitative BT inquiry. And when it comes to the use of data, there is an extensive use of non-traditional data at the early stages. And as you go to their context, to their actual, to the site, there is more use of traditional data. The next step would be to do the field work, discover the underlying practices and behaviors of those positive deviants, and designing interventions that are informed and inspired by those practices and strategies to scale them and amplify them. And finally, monitoring and evaluating the effects of those interventions in the intervention population. But the focus of the current, the presentation today would be on the first two stages, which is the problem, solution fit, and determining positive deviance. I will now leave space to my colleagues to tell you more about the Niger pilot.
Thank you, Basma. And if at any time you have any questions, please feel free to put them in the chat. I will try to respond to them on the chat if we can do so. And if not, we'll collect them and we have time for Q&A at the end of the session to respond to all your questions. Now I'll hand it over to Hassan, Eric, and Esther. So Hassan is the head of solutions mapping at the Accelerator Lab of UNDP in Niger, and Eric and Esther are working for the GIZ Data Lab, and they'll show us what a practical application of DPPD actually looks like, and as Basma was saying, focusing on these first two phases of problem solution fit and determining positive deviance. So over to Hassan. Hassan, can you hear me?
Oui, je vous reçois 5 je suis en train de partager.
Okay. Thank you.
Bonjour, chers collègues, chers participants. C'est bon?
Tu es sur mute.
Okay, give us a second while we're setting up the screen.
Vous me recevez bien?
On
Oui.
t'entend, oui. Par contre, on voit plus ton écran.
Donc, bonjour, chers collègues, chers assistants, donc nous allons vous présenter le contexte nigérien du positif Deviance Big Data. Donc, pour le cas du Niger, il s'agit d'améliorer la production agricole au Niger. Donc, pour ce qui est de la production agricole, au Niger, il faut retenir que le mil et le sorgho constituent deux céréales principales qui sont cultivées. Ils sont cultivés par environ 85% de la population. La production de ces céréales ne suffit pas aujourd'hui à couvrir les besoins alimentaires du pays. Donc, particulièrement, nous constatons ces difficultés en période de soudure. Ces cultures dont nous avons mentionné, le mil et le sorgho, sont soumises à des situations, à des aléas climatiques, notamment les sécheresses, les inondations et les effets des insécurité, notamment les problèmes d'accès aux terres, les déplacements internes liés à la sécurité et l'insécurité, les conflits sur les terres et qui sont à l'origine de l'allongement de la durée des cycles de culture. Donc, tous ces facteurs-là participent à augmenter le cycle de culture. Niger, comme vous le savez, nous avons un pays très vaste, plus de 1 million de kilomètres carrés, qui est constitué de trois zones géographiques. Notamment au nord, nous avons la zone saharienne, qui est constituée principalement du désert, qui enregistre environ une pluviométrie de moyenne de 0 à 150 mm par an. Nous avons au milieu la zone sahélo-saharienne. Nous enregistrons environ 150 à 300 mm par an. Nous avons la zone sahélienne. C'est une zone où on note la pratique de l'agropastoralisme. C'est une zone semi-aride. Nous enregistrons à ces zones une pluviométrie de 300 à 600 mm par an. Enfin, nous avons au bout, là-bas, au niveau juste au bout, la zone soudanienne, sahélo-soudanienne, qui est une zone agro-pastorale, c'est une zone également semi-aride qui enregistre environ 600 à 800 mm par an. C'est notamment la zone de Kaya dans la région de Dosso. Donc, pour ce qui est en fait du cycle de sécheresse, les facteurs dont nous avons énumérés précédemment participent rallongent le cycle de culture et entravent les mouvements de transhumance des éleveurs. Ce qui se déroule, c'est des mouvements qui se déroulent chaque année au Niger. Les terres sont encore en culture au moment du passage des transhumants et donc nous constatons une indisponibilité pour les éleveurs, pour les passeurs à utiliser ces terres, donc qui sont liées, comme vous le savez, à l'allongement des cycles de culture. D'une manière générale, en ce qui concerne le conflit entre agriculteurs et éleveurs, nous avons plusieurs facteurs. Du point de vue agricole, quand on prend, nous avons des situations liées à la perte des terres cultivables. Nous avons les situations liées au débordement des cultures sur les terres pastorales. Nous avons lié notamment à la démographie galopante, etc., etc. Nous avons la situation qui est liée à l'accès aux points d'eau, compte tenu du rétrécissement du couloir de passage des animaux. Nous avons des situations liées à l'accès au forage, contrat d'occupation temporaire, etc., etc. Et quand on prend le registre aussi des éleveurs, nous avons des dégâts qui sont liés, des dégâts de culture pendant les transhumances. Nous avons l'accroissement du banditisme grandissant de plus en plus. Nous avons l'indisponibilité des pâturages du fait des cycles de culture. Voilà, d'une manière générale, ce qu'on peut retenir des différentes causes qui entravent ces situations, ces conflits entre agriculteurs et éleveurs d'une manière très brève. En ce qui concerne les objectifs, nous pouvons retenir que l'objectif fixé à travers cette approche au Niger, c'est de rechercher des solutions pertinentes, efficaces et efficientes pour les cultures de mil et de sorgho dans les zones sahéliennes du Niger. Il s'agira pour nous d'éviter l'aggravement des conflits agriculteurs et éleveurs qui contribuent à la déstabilisation de la cohésion sociale au Niger. Et ça contribue également à renforcer la sécurité alimentaire au Niger. Voilà, sur ce, je viens au terme de ma présentation. Merci de votre aimable attention.
Merci bien. Thank you, Hassan. And over to you, Eric and Esther.
So I realized I was muted. Can you see the presentation?
Yes. But you might want to do full screen.
Yeah.
Thank you.
Is it covered by the entire slide, or do you see the presenter view?
We see the entire slide.
Perfect. Okay, great. So yeah, my name is Esther, and together with Eric, we'll present the quantitative part of our pilot. And so to measure the performance of our communities, we use the Soil Adjusted Vegetation Index, or simply SAVI, as a proxy for crop biomass or crop yield. And SAVI is a spectral index based on satellite remote sensing data. In our case, we used optical Sentinel-2 data. And in remote sensing, spectral indices, spectral vegetation indices like SAVI are developed based on the specific spectral characteristic that a healthy plant, or in our case, a healthy crop plant has. And SAVI has values between -1 and 1. So as you can see in this figure, the higher the SAVI value, the healthier the plant. And minus values or low SAVI values usually indicate dead plants or bare soil where there's no vegetation. So we chose SAVI for this pilot because it's specifically suitable for arid areas, like in Niger. Yeah, SAVI corrects for the influence of soil brightness. That can be a problem when vegetative cover is low, like in Niger. So our study area is located in the south of Niger, as Hassan already mentioned, and you can see it here. It's covered by those black polygons, where each polygon presents one community. And the entire area is very heterogeneous in terms of its structural characteristics, like temperature or soil, and therefore also poses specific challenges and interacts differently with the farmers' practices on the ground, and possibly affects their success. So to account for this diversity, we grouped our communities into different geographical zones to only compare the community's performance within those zones. And for that, we used readily available data, data on agroecological zones from 2020, and that is these zones as shown as the colorful, colorful base map here. So all these zones share specific biophysical, climatic, and land use characteristics, and also similar agricultural practices. We process different kinds of data sets to identify our positive deviance and to create the variables that we would feed our model with later on. So we used Sentinel-2 SAVI data, as I already mentioned, for the entire period 2016 to 20. Then we used rainfall data for the same period of time, land surface temperature data, soil moisture data, and soil organic carbon stock data. that one only for 1 year. And then also we had land cover data and soil type data for the same year. And the last two data sets, land cover and soil type, we used in order to calculate the class proportions per community, so per polygon. So most communities were covered by cropland, but also herbaceous vegetation, or for example, shrubland. And then the first five data sets, we only looked at the geographical extent of cropland. And to do that, we used a crop mask that we derived from our land cover data set to mask every other land cover type out. And then we overlaid this with the community polygons and calculated the annual and the monthly mean. Then I will hand over to Eric.
Thank you, Esther. And I will take over for the statistical analysis. So after processing the data, we were left with the data set of 3 years, 2018 to 2020, and 12,000 different communities, so quite a large data set. And as we are looking for deviance here, statistically speaking, we are looking for outliers, and they are very sensitive to errors in the data or to noise. And we therefore decided to be conservative in our models as often as possible. And therefore we decided to use an ensemble of 3 different models. The first, which is simply a regression model, where we split this up in several regression models by the homogeneous groups, so by the agroecological zones. The second model is a boosting model, or which in itself is an ensemble of And because we used machine learning methods, we also had to split up our data in training and test data so that we trained the model on one data set and then verified the measurements on the test set to be sure that they are not overfitting and that they are performed equally well on unseen data. And from those 3 models, we got then 3 different prediction, which we just averaged into one more stable prediction, which we used to determine our deviance. In the next slide. Thanks, Esther. So the deviance is simply the difference between the prediction and the actual SAVI value, so the residual of the model. And as we had 3 different years, and we wanted our results to be stable over, or we are looking for communities which perform well on 3 consecutive years. We just took the minimum deviance over the 3 years for every community. And below you can see the plot of these minimum residuals over the 3 years. And on the right side, you can see they are exactly the ones we are looking for. So they are the outliers from our prediction. And on the next slide, you can see them actually plotted on the map. Esther, would you please? Thank you.
Okay, thanks, Eric.
So that's the map you've seen before. Esther showed the different agroecological zones, and the highlighted red polygons are our potential deviance, which now need to be verified again. And then I would hand over to Esther again.
Thank you, Eric. All right, yeah, and so before deciding which potential deviance should actually be visited in the field, we had to make sure that we wouldn't include any false positive deviance. And for that, we follow this exclusion logic and used very high resolution satellite imagery, as well as information on structural characteristics, and then manually validated and explored each community with our local domain experts. So one aspect was the accessibility. If a community wasn't accessible due to, for example, safety reasons, then we excluded that one. Another aspect were water resources, whether they were close by, like river basins or lakes, because if so, that would increase the likelihood that cropland is actually irrigated and not rain-fed. So in that case, we would also exclude this community. And then another aspect was the accuracy of the crop mask. Sometimes we had the problem that the crop mask included other land cover than cropland, for example, shrubland. And in this case, we also excluded the community. And then the last aspect or question was whether the performance was driven by other land use rather than rain-fed plots, for example, by pasture or forest. And if not, then we included this community in our group of potential positive deviants. So this is just to show you one example of a false positive deviance. You can see the community that's marked by the outer polygon here. And it had very little crop pixels according to our crop mask, which when we zoomed in, we found that it actually represents shrubs instead of crops. So we excluded this one. And this is another example for a false PD where we had the problem that the strong performance was caused by the existence of irrigated crops along a river basin here in the north of the community. And yeah, so here the high SAVI or biomass values came mainly from this irrigated cropland area instead of from the rain-fed cropland area, which you can see here in the south and has lower SAVI values that is indicated by the light green colors. So the dark green colors, they represent high biomass values. And then here you can see an example for a potential positive deviant that we didn't have to exclude. This community was characterized by, on average, high performance. And this is an example here of how rain-fed cropland looks like. In this case, we didn't see any signs of potential irrigation, so we concluded that this is a valid positive deviant. And a last example of a potential positive deviant is this one here, where the high SAVI performance came mainly from this area that is marked in blue, where you can also see the dark green colors that indicate high SAVI. And when we zoomed in, we found these contour bands, these lines that you can see here. And our Niger team, or our local expert, they confirmed that these are intervention types that consist of lines of stones along the natural rises of the landscape and act as a barrier to collect rainfall, so to avoid erosion. And these contour bands are either sown with forage species or just to protect, to let vegetation regenerate naturally. So these possibly led to the high biomass, and therefore this community is, for example, very interesting to explore. Yeah, and with that, I would hand back to Andreas.
Yeah, thank you, Esther, Eric, and Nassan for this presentation, or the presentations. We're opening up for question and answers, and then I have Jeremy join me because my French is a little rusty. So if you have any questions, be it in French or in English, feel free to ask, put them in the chat. Yeah. And while you're maybe typing in your question, probably gives Jeremy and myself some time to ask questions ourselves. So I'll start with a question on the last slide that you actually showed, Esther. And this is a question into Esther, Eric, Hassan, maybe also Basma. Or more of an observation, actually. So it seems that we might not only be able to identify positive deviants, but even some of the practices that positive deviants apply. Is that correct, or is that an assumption, or to what extent can we already say that what we saw on your last slide might actually be a positively deviant practice that that might be scalable actually? So I don't know, it might be a question to Basma maybe, or Eric and Esther, feel free.
Esther, do you want to respond, or shall I respond?
Feel free to respond. Thanks, Basma.
And maybe you can switch on your video if you're responding so that we can see you.
Okay.
That's okay. Did you get the question, or shall I repeat it?
Yes. So you were talking about if it's an intervention that is community-based, Andy, or is it like an intervention based on a development program, for instance?
Yeah, I mean, I guess that would be the second question. I think the first question is actually, well, can we already say that we're able to also identify practices only in the quantitative phase, because we haven't done any field work yet? So based on the last slide, and as Esther showed, or is this too early to say, or too early to yet to say, because we need to verify it first?
Okay, so from the validation for some of the villages, we were able to identify potential PDs who are having development interventions that we know happened maybe in 2016 or 2017, I'm not sure. But it was interesting to see that the effects of those interventions are still valid until now. So this was the case for some potential PDs. And for other PDs, I'm not sure if this one was one of them. There are those practices that we know that they are for soil and water conservation, and they could be practices that are already developed by the community and not by an external development intervention. And we're seriously interested in both types of interventions. We're interested in the ones that are developed by the community, and we're interested in the ones that have been developed by development interventions earlier, and they are still having effects and impact until now, in order to understand what context and what are the reasons that are enabling them to still have an effect until today.
Thank you, Basma. There's two more questions. I'll start with the one by Nicholas Wilco, and then I hand it over to Jeremy for the question by George Besankakpo. And I would ask you, whoever responds to the question, to speak slowly so that Jeremy gets a chance to translate on the chat. So the question by Nicholas goes as follows. When throwing out PD candidates, so potential PDs, I would assume, were there any borderline cases that were only just excluded but came close to being PDs or being potential PDs? If yes, do you still look at them with half an eye to find PD strategies or PD practices from them?
Yes. Well, in response to Nicholas' questions, yes, there were a number of villages that were borderline. We weren't sure for a few things. So we weren't sure if it's accessible to go there because they were in the border with Nigeria. So that was one reason to have them as on the borderline. Another reason was that we weren't sure if there are irrigation there. And the next step would be to do a validation with stakeholders to make sure that there is no irrigation or there isn't something that is structural that is driving the performance. And that will be when we can bring them back to the list of true PDs that are worthy of a field investigation. But we never throw them away, so we always have them as plan B.
Okay, thank you. Jamie, do you want to read out the question by George, or shall I?
Yeah, so for George's question. Donc là, en français, la question est quelles sont les sources de big data et comment elles ont été collectées, j'imagine, et comment est-ce qu'on s'assure de la qualité. So in English, I guess it's a question about quality assurance in the data that were used. Maybe I can spin this slightly for the answer and then open it maybe to Esther for the answer. I think there's an interesting discussion here to be had around, we're looking at two different types of satellite imagery with different resolutions at the beginning. And how do we go from one to the other? What was the rationale and why, what is the improved or higher quality of the sensor data that we ended up using?
All right, so the question is how we sort of fuse those data, Jeremy, or?
The question is really about using data or using light imagery in this case, and maybe you're just saying you can maybe describe the switch from one to the other there. Yeah.
Yeah, so yeah, I mean, it is true. We had very different spatial resolutions for the different data sets. So for example, for our SAVI data, we had quite a high resolution of 10 meters, and then for rainfall, it was rather coarse, 5 kilometers. But we all aggregated the different data at the same level of spatial resolution. So by that we merge them, but it is of course important to note that some data sets are a bit more precise than others, like rainfall, which was rather coarse.
Thank you. Thank you. Yes, George has a couple of more questions. Maybe I'll first take Gunnar's question, if that's okay, and maybe in the meantime, Jeremy, you can look at the other two or so questions that George asked. So Gunnar is saying that you mentioned that in some of the villages you know about past interventions. Would this imply that it's also possible to look for interventions which did not have a lasting impact? Maybe that's one for Basma.
Yes. So yes, Gunnar. So when looking into positive deviance, it's important to look also into negative and average deviance to be able to identify those factors that are distinguishing the positive deviance. And the same case would also apply on the ones where interventions work, the exception of responders. So it would also make sense to see which villages are responding well to interventions and who are not responding well, and trying also to make this distinction. So this is something that we are planning to include in our compare group.
Thank you, Basma. And maybe while Jeremy is translating this, George has more questions. One on what other sort of sectors or domains can you apply DPPD? Maybe that's an easy one for you, Basma. And then I leave the other question to you, Jeremy, that George asked. So what other domains lend themselves for DPPD and why so, maybe?
Sorry, Andy, what are the sectors? Can you repeat the question?
What other sectors apart from agriculture or other domains apart from agriculture lend themselves to DPPD and why so, and why someone, maybe why not others?
Okay, so from our experience applying DPPD, it turned out that like Earth observation data is the low-hanging fruit of DPPD. And being able to observe performance using remote sensing data turned out to be a very viable alternative. So I would phrase it in whatever performance that can be observed using remote sensing data could be a very good like a very good candidate to applying DPPD. So it could be like agriculture. This is one sector. It could be like the rangelands monitoring, which is we're doing in Somaliland. It could be identifying forest changes, which is what we're doing in Ecuador. Other opportunities could be online data. Like one application that I applied DPPD for, which was part of my PhD research, was applying it in research performance. So the existence of like publications on Google Scholar and being able to track performance, like citation performance, and this is somehow, there is somehow like an implicit consent by the units of analysis, which are the researchers, to track their performance. And this made it, again, a good domain to observe performance. But again, there is the problem of privacy. And that's why we're coming again to realize that when it comes to applying DPPD, it's always good to look into units of observation that are beyond individuals. And this way we would ensure that we are not breaching the privacy and invading the privacy of our observed units.
And maybe just quickly adding to that, as I was saying in the beginning, we're working on a handbook, a guide on how to apply DPPD, and many of the questions and the points that Bassem was just making in terms of how do you decide which problem to address and what sector to work on, what data to use. Also, when it comes to data privacy, will be part of that handbook that we're currently compiling. Okay, over to you, Jeremy, maybe on the third or second question that George put here.
Yep. So sorry, I'm just going back up to it. Mais peut-être, Georges, tu peux ouvrir ton l'action de l'homme sur
Jeremy, you're breaking up a little again.
Sorry. I was just reading through the question and asking if Georges could maybe open his microphone and specify the question a little more. So the question here is framed is how does statistical models ensure that human intervention on the ground models, but what that means?
I'm sorry, Jeremy, you were breaking up a little bit. Can you repeat this question?
I was just translating the question as it is, but it's not quite clear to me. So how do the statistical models ensure that human intervention on the ground, so when we go to the field and when we try and amplify the good practices of positive deviance, won't modify the results? What I'm not clear about in the question is, if I understand the question correctly, this is actually the intent.
Yes. And also one assumption is that, I don't know if this is what Joshua meant, but how are we controlling for interventions that are already there when we're predicting positive deviance, maybe?
Maybe you can respond to that, although you mentioned it slightly before.
But yeah,
so,
but yeah.
Sorry, he's just specifying. So what he's saying is that we're not taking into consideration human-related data, so anything related to practices themselves in the modeling. So indeed, then, I mean, I understand the question. Yes, if we're not taking into human intervention, so the actual practices that these farmers have, then indeed our models are off as soon as we see. But the point of having the models is to identify them so that we can change or help amplify practice. Correct.
First, I muted you. Yeah.
Yes, adding to what you said, Jeremy, is that the whole point of the modeling is to try to control for all the structural and contextual variables that are on the ground, and trying to use them to explain part of the performance, so that the remaining part that is not explained, which is captured by the residual, is what we're going to observe on the ground. So as Eric said, what we're trying to do is that we're trying to predict the ones who are performing better than what was expected given the contextual factors that they are living in. So the beauty of identifying positive deviance this way is that this way we're saying that there is a variance in performance that wasn't explained by the structural variables. There is variance that we're not able to explain using the data that is available. And this is why we will go to the field and try to explain this variance using the qualitative inquiry. So the qualitative inquiry is supposed to help us identify those additional factors that you were talking about, or we are interested in identifying, and those are the ones that we are going to amplify. I don't know if this answered your question, Joshua. George, sorry.
I see that. And with that, I'll hand it over to Catherine Vogel, who is the co-leader of the GIZ Data Lab and leading the initiative on part of GIZ for closing. Over to you, Catherine.
Thank you so much. So I'll try to start in French. So merci beaucoup à tous les présentateurs, non seulement pour les présentations, mais aussi pour tout le travail acharné sur ce sujet pendant les derniers 12 mois à peu près. Et merci à tous pour votre temps, pour les questions. Et j'espère pour aussi votre enthousiasme pour cette nouvelle méthodologie. Et si vous souhaitez de rester en contact avec nous et discuter davantage, ou si vous avez une idée pour appliquer la méthodologie, le DPPD, vous trouverez dans le chat tous les détails des présentateurs et tous les groupes. Et nous avons aussi un blog très vivant. Nous avons récemment publié un post sur le Niger. Et vous aurez également accès au enregistrement de ces webinaires et des 3 autres que nous avons effectués, le Mexico, Ecuador et Équateur et Somaliland. Et nous allons aussi développer d'autres matériels de support, etc. Donc, restez en contact et merci beaucoup pour votre attention. So now in English, thanks to our presenters for not only the presentations, but for all your hard work you've been doing during the last, 16, 17 months. Thanks to all for your time, for your questions, and hopefully you're so excited about this methodology than we are. If you have an idea of how to apply DPPD, if you want to discuss more, if you want to learn more, don't hesitate to get in touch with us. And you will find all the details in the chat. There was just a blog post published on our pilot in Niger and also on the others. There's one on Mexico coming soon. You also have access to the these webinars, the recordings. And we're gonna develop more information. We're gonna develop more support material, like a cookbook, etc. So please stay in touch. And thanks again, and stay safe. Have a good evening to all of you. Thanks.
Thank you. Bye.
Thank you. Bye. Bye.